Okay, plan for this recording is to talk through the worksheet. It says chapter 4, but it's chapter 6. Talking through how to solve, how to use our properties, and word problems. So let's get rolling. So one kind of problem that you'll see is when you have an exponential equation, an equation with exponentials in it, when you're trying to solve and you can make the bases the same. So one kind of problem is try to make 8 and 16 have the same base. Can I take a number and raise it to a power, take the same number, raise it to a different power, and get 8 and 16? Answer, yes. 2. If I take 2 to the third power and 2 to the fourth power, I get 16 and I get 8. So the bases are the same. So if I have a power raised to another power, I multiply my exponents, right? If I have x squared cubed, you multiply these exponents. That's all I'm doing here. Multiplying that times that, multiply that times that. When I multiply over here, I have to distribute. So one kind of problem is look at your bases and ask yourself, can I change them? Smaller number, 99.9. I can't think of a time when it's not going to be smaller. Okay, I don't like the word always though, but change it to a smaller number. So what times itself, however many times, gives me 8 and 16, and I can make it a 2. Now that the bases are the same, let's just think about this. I need to take 2 and raise it to a power. That needs to be 2 raised to a different power. Well, the only way that this can truly be equal is if the exponents are the same. I can't take 2 to an exponent, take 2 to a different exponent, and expect them to be the same value. So clearly, my exponents have to be the same. So I just drop the bases, and I ask myself the question, how will x, what value for x will make that the same? And we're back to a linear equation. Get all my variables on the same side, so I'm subtracting 12x from both sides. Divide by -9, and x equals -4. Okay, all right. Question 2. First step, can I make the bases the same? Well, I really don't have an exponential over here because there's no exponent. However, I could make it an exponential, but I can't make a 5 and an 18 the same, and I got this 2 here, so I'm going to try to get the exponential term, this term that has the exponent, by itself. How do you undo multiplication? We divide. It doesn't matter if it's an exponential equation, if it's a linear equation, it doesn't matter. To undo multiplication, we divide. Now I'm going to ask the same question. Can I make a 5 and a 9 have the same base? No. So now I have a new technique. From here on down, for the rest of this page, we're doing what I'm doing right here. I need to take the log of both sides. It doesn't matter if you use ln, and remember what ln means. Ln means log base e. So it doesn't matter if I use ln or if I use log, which is implied base 10. Okay? It doesn't matter in this case. Sometimes one's a little bit easier than the other, but in general, it doesn't matter at all. Okay, so I'm going to use log, mainly because I did ln in class. So I'm going to take the log of both sides. So log of 5 raised to the x power equals the log of 9. Think about your properties of logs. When there is a variable in the exponent, or if any exponent, I can move that exponent down in front. So the power property of a log allows me to take this x out of the exponent. When you are solving, or when you're doing almost anything, make sure you know why you're doing it. Why did I take the log of both sides? So I can use my properties to get access to the variable that's in the exponent. I need to get it out of the exponent so I can use it, so I can solve for it. By taking the log of both sides, it allows me to bring this x down in front. Remember, the log of 5 is just a number. It's asking the question, 10 raised to what power is 5? It's just a number. So this is like 3x equals 12. How do you undo multiplication? You divide. So how do I undo multiplying by the log of 5? I divide both sides by the log of 5. Okay. Sorry. I didn't know. I'm going to hit pause and get my calculator going. Give me a second. So my T84 trial license is gone, so I'm going to have to use my Inspire. So right down here, you can see the log and ln. There's an ln right there. There's a log. On your 84s, they're going to be right down here on this side. You're looking for log or ln. The one I used log, so I used common log. So that's what I'm going to type in. Okay, I'm going to type in the log of 9 divided by the log of 5. So I'm going to go on mine. I got to go second. You don't on yours. Log of, oh, these fancy calculators allow you to do a different base. Log of 9, get out of there, divided by log of 5. And I'm not going to do this every time. I just wanted you to see it done once. Log of 9 divided by the log of 5, hit enter, and I got to hit it approximate. You get 1.36. Okay, so there is the question number 2. Get rid of this. I don't think I'll come back to the calculator. I think you can do the calculator work. Okay, and they don't really apply because it's the wrong calculator. Sorry. So we have x equals 1.36, or x equals that exact value. Okay. Now, from here on out, from the rest of this page, the goal is to get the exponential term by itself, get it to this step right here, take the log of both sides, and solve. Okay, so here, to get rid of the 2, I divided. Here, to get rid of the negative 3, I add. So 3 to the x equals 12, and I'm right back to this step right here. Take the log of both sides. This time I'll use ln just to switch it up a little bit. Makes no difference. Bring the x in front. Divide by ln 3. And x equals the natural log of 12 divided by the natural log of 3. That is not the natural log of 4. That is not the natural log of 4. Actually type in the log of 12 divided by the log of 3. And I want to show you just because I think you need to see it. The natural log of 12 divided by the natural log of 4 is equal to that value. Let me get an exact value. Whoops, wrong button. Let me get an exact value. So then I'm going to do the common log, no base, common log of 12 divided by the common log of 4, base 10. Notice they are the exact same value. If I can get it to both fit on the screen. 1.79 for the log, log, 1.79 for the natural log, ln. They're the same value. It doesn't matter which log you choose. There are times, and I'll talk about them, when one might be slightly easier than the other, but that's it. Okay. I think this one didn't show up right on the answer key. I think the back answer key wasn't 1.7. No, it says, where'd I go? Question 3. Yeah, it says 2.26. So that one, for some reason, I didn't type in right earlier. Okay, question number 4. It is already isolated, so I'm going to simply take the log of both sides. I'm going to bring the exponent down in front, and you need parentheses. That entire exponent is being multiplied by the log of 2. Okay, not just the negative 3. It's the entire exponent. So I need the exponents for you to be in parentheses. I need to get rid of the log of 2. You could distribute that, but I wouldn't. I'm going to get rid of the log of 2. That log of 2 is being multiplied by what I'm trying to solve for. So I'm going to divide both sides by the log of 2. Trying to solve for x. I have this minus 3, so I'm going to add 3. Grab my calculator and type in log of 7 divided by the log of 2 plus 3. Once I get the log of both sides and I get the variable out of the exponent, it's just algebra. Don't let the log confuse you. This is just a number. This would be like x minus 3 times 4 equals 7. It's the same thing. Yes, I could distribute that, but it's easier just to divide by that. Okay, don't let the log mess up your algebra skills. You know how to solve these equations once the variable's out of the exponent. Okay, first step, I want to get that by itself. So I'm going to divide both sides by 5. And I have 10 raised to the x minus 6 equals 7 divided by 5. I would not go to a decimal there. You could because it's a nice decimal, but I'm going to leave it like that. Take the log of both sides. And I'm going to bring the exponent in front at the same time because we're getting better. I'm going to use log. And in this situation, that's a better choice. Not the correct choice, a better choice. Here's why. What is the log of 10? Log of 10 is asking the question. Remember, it's base 10. So the log of 10 with a base of 10 is asking the question. Let me throw a variable over here because I don't know what the answer is. 10 raised to what power equals 10? That is the question that a logarithm is asking and answering. So the answer to this is 1 because 10 to the first is 1. Or sorry, 10 to the first is 10. So the answer to this is just 1. And 1 times anything is just that thing. So in this case, it makes more sense to use a common log, log, compared to a natural log. If you did not do that, at this point in time, you divide by ln of 10. And that's totally fine. It just saves you one step. Like I said, it's not right, not wrong, just maybe a little easier. I want to get rid of the negative 6, so I add 6 to both sides, and I get my answer. Grab a calculator, type that in, and you should get the answer that's on the back of the worksheet. Okay. Hopefully, at this point in time, you can start hitting pause, do them on your own, and come back. You have to get to that point. I am not going to be walking through these questions with you on the test. You have no help. You have yourself. Get to the point where you can do them on your own. Okay. Hit pause if you can and try it. First step, get the exponential by itself. So I added 7 to both sides. This was base 10 for the exponential, so I used base 10 for my log. This is base e for the exponential, so I'm going to use base e for my log. So I bring the 2x in front, because again, we're getting better, and we can do 2 steps in 1. ln of e, same question I asked earlier about the log. ln of e is log base e of e, which is asking e to what power is equal to e. Same answers over here. This base is 10, so the answer is 1. This base is e, so my answer is 1. So that goes away, and I get 2x equals the ln of 15. Divide by 2, and x equals ln of 15 divided by 2. If you used log, common log right here, you would just have log of 15 divided by the log of e. Same thing. You'd get the exact same answer. And I'm not going to the answers to the approximate because you have them on the back. Okay. Hit pause. Okay. I have already the exponential, there we go, is already isolated. So I'm going to take the log of both sides, bring the 5x down in front. In this case, the 6 is not a 10, not an E, so I can pick whichever one I want, ln or log. I picked log because I want to divide by whatever's being multiplied by my x. I want x by itself. 5 is being multiplied, log of 6 is being multiplied. I'm going to divide both sides by the log of 6 times 5. That goes away, and I get x equals. When you type, when you type this into the calculator, you're going to go log of 3,000. It's going to put a parentheses here. You need to close it, divided by, and it'll give you a divided by, parentheses 5 times the log of 6. That will give you the right answer. Or go to the log of 3,000 divided by 5 equals divided by the log of 6. Now this is one that in the back, I don't know why I typed it in. It doesn't come out right. I think it's 1.99, not 2.06 or something like that, 1.8 something. But I'll let you type that in. Right. Same steps. I'm just going to erase this. Number 8. Give it a try. Divide both sides by what's being multiplied. That goes away. And I get e to the x plus 1 equals 9. I'm going to use ln. I'm going to bring the x plus 1 down in front. And I'm going to throw a parentheses around it. If you got rid of this because you knew the ln of e is 1 and you just went right to here, in my opinion, that is totally fine. Not just totally fine, I think it's awesome. Subtract 1 and you're done. Hopefully these are getting easier. I'm going to stop. Hit pause. Whoops. Add 14 to both sides. Divide by 3. Had to check, make sure it was recording. It'd be a bummer to do all this and have it not recording. I get e to the x equals 25 over 3. I would not go to 8.3 repeating. Then I'm going to take the ln of both sides, bring the x in front. Ln of v is 1, and so my answer is ln of 25 over 3. Okay. 10. Divide by 3. Take the natural log of both sides, or common. Bring the x minus 1 in front. Ran out of room. Wrote too close. There's a variable in the exponent. Take the log of both sides so you can get the variable out of the exponent. That comes in front. Divide by ln 5. Add 1. And you got it. Variable, or the exponential part's already isolated, so I'm bring the 1/3 down in front. ln of 3. Let me do one long ways, just in case we are confused and I haven't done it in a while. I'm going to do the log of both sides, not dropping it down in front first, just so you can see my steps and I don't skip any. take the 1/3 x that's now in the exponent, move it in front. That is why I took the log of both sides, so I can get to that exponent. Otherwise, that variable is trapped up in the exponent and I can't touch it. Now I'm going to divide by ln of 3, both sides. And I get 1/3 x equals ln 8 divided by the ln of 3. I need to get rid of 1/3. How do you undo dividing by 3? Or how do you undo multiplying by 1/3? I multiply by the reciprocal, or I multiply by 3. And so x equals 3 ln 8 divided by ln of 3. You could have got a decimal here and then multiplied by 3. This is just your exact value. And the question says write an exact value and then round to nearest hundredth. On the test, we're not going to be picky. We'll take the decimal or the exact value, whichever one the directions tells you to do. Okay. Notice these are the same question, but one has a fraction in the exponent, one doesn't. But the steps are the same. So I'm going to skip this step. I'm just going to go 2x because I know that 2x goes in front. Divide both sides by 2 and by ln 3 because they're both being multiplied. Divide both sides by 2 and ln 3. And again, I'm assuming you can type that into the calculator. I'm not sure if that's a good assumption, but I think it is. Yeah, I wish I had. Right, so I just jumped over the internet real quick. And I grabbed a picture of what you have. There's your log. There's your ln. See right above the ln, the second, we go second and the blue. There's your e to a power, and there's 10 to a power. So if you're looking for e to a power, there's where it's at. There's your log, there's your ln, and you can type it in. Okay, I wish I had my Smart View available, but it's, like I said, my license has expired and we haven't got it renewed. All right, question 13. Isolate the exponential. It may look like it is. It's not. There's this negative sign here. I need to get rid of that negative sign. Technically, that's a -1 sitting there. So I'm dividing by -1. That makes that a +9. Now I'm going to take the ln of both sides because it's spacey. Ln of e is 1. That goes away. Add 3 to both sides. Divide by 2. And I got my answer. Okay, 14. Exponentials by itself. I've used a lot of ln's. Let's do something different. Divide. And I get x equals. Hopefully these are getting better. Question 15, add 1 to both sides. Here's a situation, I don't need to do the log of both sides. Are my bases the same? Sure. This is an exponent of 1. What has to be true? X has to be 1. Don't miss, I shouldn't say don't. Try not to, like I'm scolding you. Try not to miss the straightforward ones. You could have taken the log of both sides and done all that work, but a lot of extra work. Okay, so there's solving exponentials. We are going to do that again in word problems. Okay, so remember you get the formulas on the test. So here's your formula sheet that you get on the test somewhere. Formula sheet. Maybe not. Somewhere. I thought I had it. Oh, there it is. So you get this formula sheet on the test. I'm looking down here, looking at all these different equations. So a group of yeast cells doubles every 4 hours. I'm thinking basic y equals a b to the x, exponential growth. Y is not percent growth, it's not compound interest, it's not compounding continuously, it's basic exponential growth. My y is what I end up with. It does not have a value plugged in when I'm writing the function. My a value is what I start with, that is 100. There's a population of 100 at time equals 10 a.m. I am going to call this time equals 0, and everything will be based upon 10 a.m. when I start counting. Okay, doubles every 4 hours. So doubles, my growth rate is 2 every 4 hours. So I have to have t divided by, or x divided by 4. If t is 4, this exponent is a 1, meaning it doubles once. If t is an 8, the exponent is a 2, meaning it doubles twice. Okay, determine the population at 5 p.m. and we start at 10 a.m. From 10 a.m. to 5 p.m. would be 7 hours. So we're going to plug in 7 into our x value, t value. So we have 100 times 2 to the 7 over 4. Put your calculator, type in 100 times 2 raised to the, but be careful. On your calculator, you're going to go times 2 raised to the 7 divided by 4. And your calculator is going to do it the way you typed it, which is not right. This is 100 times 2 to the 7th divided by 4. And you need to make sure you throw parentheses around there. There are some calculators, like the newer operating systems, where it's going to stick your answer up in the exponent. If you can see it typed like that up in the exponent, then you're okay. But if it's like this on a single line cruising across, you must have parentheses around the exponent. Okay, answer to that one should come out to be 336 cells. Okay, determine algebraically when the population will reach 2,000. I didn't give myself very much room. So my y value is now 2,000. Same expression over here as in letter A. Divide by 100, just like we're solving back on the whole first page. Take the log of both sides. Whoops, that's an equals. We'll bring the t and the 4 down in front. Divide by log of 2. Undo division by multiplying, so we'll times by 4. Okay? Type that in the calculator. You should come up with 17.29 hours. Question 17. Sample population of plutonium-238 has a half-life of 88 years. Basic exponential growth. Y equals A times B to the X. 90-gram sample, that's my starting amount. The 238 means nothing, it's part of the name. My half-life says my growth rate is 1/2, and it takes 88 years to cut in half, so this is going to be T or X over 88. How long will it take for this to go to 40? So I plug in 40, and I just repeat what we've been doing for the whole entire recording. Take the log of both sides. Oh, sorry, I haven't done that yet. Divide by 90. 40 over 90 is 4 over 9. Take the log of both sides. Bring the 88 and the X down in front, and hopefully you followed me doing multiple steps in one shot. Divide by 90. Divide by 90. That goes away. Take the log of both sides and so on. Sorry, I shouldn't skip steps. Whoa, didn't want to do that. Yep, I'm not going to get a hold of that. All right, I'll just write them over here. So this becomes 4 over 9 equals 1/2 to the x over 88. And then I took the log of both sides and dropped that in front. That's how I got to there. All right. Next step, trying to get x by itself. Divide by the log of a half. Divide by the log of a half. That goes away. Multiply by 88, right? Trying to get rid of that. So I get 88 times the log of 4 over 9 divided by the log of 1/2. And these technically are in parentheses. Grab a calculator, type that in, and you get what x equals. Answer should be 102.95 years. Number 18. I won't skip any steps. I won't combine any steps. Okay, here's key transition or key change. Growing at a rate of a percentage. So now I'm using the amount equals principal times 1, and it is growing, so it's going to be plus 2.7% and so on. Okay, so that's the formula I'm using. Why? Because it's percent growth and not doubling or tripling or whatever. So amount equals population to start in 2012 is 18,450. My growth rate is 1 plus 0.027. Raised to the every annual, so every year, so raised to the x power or raised to the t power, either way. So there's my equation. How long will it take for the population to double? Well, I got to figure out what is double of 18,450 to know what I end up with, right? But can I give you a hint? If I put in, whatever that is, 36,900, we'll just do it. If I put in 36,900, which is 18,450 times 2. What's my first step? To divide by this, right? And when I divide by this, I get right back to the 2 that I want to happen. I want it to be double. So really, I want to know when is the percentage 1.027 raised to some power. How long will it take that to double? How long will it take for this to become a 2? Take the log of both sides. Bring the x down in front. Decided not to skip any steps this time. Divide by log of 1.027. Grab a calculator, type it in. Answer should be 26.02 years. Okay. Number 19. Population of yeast can double. Okay, we're back to y equals ab to the x. It doubles every 2 hours. Assume the initial population is 120, so we have 120. Doubling every 2 hours. Question B. Use your equation, determine what the population will be after 12 hours. So it's going to be 120 times 2 raised to the 12 divided by 2. 12 divided by 2 is 6, so I'm going to go 120 times 2 raised to the 6th. Grab your calculator, type it in, see what you come up with. Answer I come up with is 7,680 cells. Question C. Determining how many hours it would take to have 500,000 cells. So I'm going 500,000. 120 times 2 raised to the x or t over 2. Going to divide by 120, and I get 50. Take the log of both sides. I thought that looked wrong when I said that. It's not 50. It's 4,166. I looked at the wrong problem when I was grabbing my calculator work. Okay, so now we take the log of both sides. I'm using log. Why? Because I want to. Divide by the log of 2. And I get x over 2 equals the log of 4,166 divided by the log of 2. Multiply both sides by 2. And I get x equals 2 log, etc. When I type that into the calculator, final answer, 24.0 hours. Five. Okay, number 20. Antique painting is purchased in 1980 for $955. Values decreased by 3.1%. I don't have basic exponential. I have the y, or the a equals initial amount times 1, in this case minus 3.1%, and it's raised to the t years. Determine algebraically when it's worth 50 bucks. So plug in 50. Let me do this one. This comes out to 0.969. Just makes it a little easier than typing that big mess in. Divide by 50. Take the log of both sides. I'll use ln just for the fun of it. Divided by, notice I kind of skipped a step there, but I think we should be getting better where we can do that. It's always going to be that natural log of that divided by the natural log of that, or common, either one. Final answer, number 20, should be 94.97 years. All right, 21. $1,000 invested, 2 accounts, both paying 9% interest. One is compounded quarterly, one compounds continuously. So those 2 quarterly. Principal, $1,000. 1 plus interest rate, 0.09. Number of times compounded, quarterly, 4 times, and a t. Find the difference between the accounts after 20 years. So I grab a calculator and I type in 20 for t. 20 times 4 is 80. And when I grab a calculator and type that in, I get $5,930.14. Compounding continuously, that's PERT. So amount equals principal. But now it's e raised to the RT. And t was 20. Grab a calculator, type that in. Remember, it was second. ln is how you find that. Second natural log is the e to a power. And when I type that in, I get amount equals $6,049.67. And the question asks me to find the difference. I subtract them, and the difference is $119.50. Whoops. Question 22. Just simplify. 1/4 raised to what power is 1 over 64? Answer, 3. Why? Because 4 times 4 times 4 3 times is 64. Oh, Minogue, what are you doing to me? Look at letter C. How in the world are we going to do that thing? Start on the inside. Log of 81 base 3. Get an answer. What is the log of 81 with a base of 3? 3 raised to what power is 81? 4. 3 times 3 is 9, times 3 is 27, times 3 is 81. So this is a 4. So now we have log base 10 of the log base 4 of 4. Well, this is asking the question, 4 raised to what power is 4? Well, that's easy. That's a 1. And what is 10, or 10 raised to what power gives me 0? Well, anything raised to 0 power is 1. And that's the only thing, is if x is 0. So this whole entire mess is 0. Okay, 1 over 5 raised to what power is 25? How do I get a base raised to a power to get a whole number? It needs to be negative. How do I make a 5 a 25? It needs to be a 2. So this is negative 2. This was equal to 3. That was equal to 0. Jump down here. 7 raised to what power is 343? 7 squared is 49 times 7. So that's 3. This one's tricky. Log of 10 base 10. Well, we just learned a new property to make this one easier. That 12 can slide in front, right? And this becomes 12 times the log of 10 base 10. Well, we've already talked about that as just 1, so 12 times 1 is 12. This one we've already talked about because this can go away because the bases are the same. And if we don't like that, let me show you why it goes away. I don't know what the answer is, so I'm going to stick an X out here. I'm going to write this correctly. So 10 raised to the log base 10 of 5 equals X, right? Because I don't know what it is. I'm going to switch forms. So this is like 3 to the X equals 5, right? The base to an exponent equals a number. So this base of my exponential is the base of my log. The answer to my log is the exponent, always, right? Where we did it right here, 7 to the third power. The answer to my log is the exponent. And what I'm taking the log of, in this case, has to be x. Just double check. 10 raised to this mess equals x. 10 raised to this, yep, we got it. So what is x? Log of 10 of x has to be the log of 10 of 5. Log base 10 of 5. Well, x must be 5. So if these are the same, 10, 10, then the answer is just that there. Add them together, we get 17. Okay, 3 over 2 raised to what power equals 27 over 8? I liked 3 for this worksheet. X equals 3. Okay. I think we're over halfway done. Okay, we're doing properties. We're just going to expand this thing. Take a second, hit pause, try it. Okay, so what's my rule for when I know I'm done? Single variable inside the log and no exponent on that variable. So use my product property, and now I'm going to use my power property. We've done the power property lots already on this worksheet. We're done. Single variable inside the log, no exponents. Okay, hit pause. Log of the top minus the log of the bottom. Split the first one into log of the first plus the log of the second. Bring the exponent down in front. And we're done. Single term inside, no exponents. Go the other way around. Remember what we said in class. When you're doing your expanding, whatever's on the bottom will end up being a negative, and whatever's on top will end up being a positive. I'm going to use that immensely right now. Hit pause, give them a try. Okay, I need a single logarithm. Before that, I'm not going to skip any steps for the first one. I will skip a bunch of steps for the second one. I'm going to do it all in one shot because we're smart like that. So my first step is I'm going to bring all of the coefficients up as exponents. Bring the 4 up, bring the 3 up, bring the 2 up. Okay, like I said, single logarithm, so log of a. There's going to be a fraction because I have a negative sign. All my positive will be on top. So x to the 4th will be on top, y to the 3rd will be on top. All my negatives will be on the bottom. 7 squared is 49, so there'll be a 49 on the bottom. This fraction is in line with the logarithm. It's sitting on top of that line, and the only subscript I have is the a. So same thing, log base a. Every positive will be on top. Every negative will be on bottom. 2 is on top. It's the only positive logarithm. These are both negative. There's no exponent. Sorry, there's no coefficient, so there's no exponent. The coefficient becomes the exponent. Technically, that's in parentheses, and again, technically, that's all on the same line. Okay, 25. Switching gears, kind of go back to word problems. Keeping you on your toes. Amount equals principal 1,300. Compounded quarterly, so I have the 1 plus 0.09 divided by 4. And it's raised to the 4t power. How long will it take for this to increase to 2100? So that's what we end with. We probably could grab a calculator and get a decimal here. I'm just not going to. Divide by 1300. And I get what, 21 over 13. Again, you can go to decimal. I changed my mind. I'm gonna go to decimal on that one. Was that 1.0225? Okay, take the log of both sides. Bring the 4t down in front. Divide to undo the multiplication. And they need to divide by 4, so I'm just going to do it all in one shot. Dividing both sides by 4, ln of 1.0225. That goes away, and I'm left with t. Grab a calculator, type that mess in. You should get, wait for it, 5.39. Okay, switching gears. Done a lot of exponential solving. Now we're going to solve some logarithms. Okay, solving logarithms. 2 ways you're going to see this. You're going to isolate the log and switch forms into exponential. 3 ways you're going to see this. You're going to use your properties to get it to a single log so that you can write it as an exponential. Or you're going to come down to a case where the logs have the same bases, just like we did with the exponents, and then we're going to drop them. So those are our 3 different setups. So I have a log, 1 log, single log, isolated. I'm going to switch forms. Why? So I can get to the x, get rid of the log. I can't touch this until the log is gone, and I need this to be x equals, so I have to get rid of the log. I'm going to switch forms. 3 to the 5th equals 2x plus 1. So 3 to the 5th minus 1. Divide that mess by 2. Final answer, 121. That's after I divide by 2. Okay, now I have 2 logs. Use your log properties. We just did some up here, right? We just condensed them right there. Write each expression as a single logarithm. Write this expression as a single logarithm. It is division, so it's going to be the top over the bottom Have a log here, need to get rid of it. How do I get rid of it? I can switch forms. Why do I need to get rid of the log? Because my goal is to get this to be x equals. I can't touch this until this is gone because we are taking the log of that. So I'm going to switch forms. 10 to the negative 1 equals x over x plus 3. You can make that a decimal, totally fine. And then we're going to multiply both sides by x plus 3. Can I show you one more thing though? What a decimal is totally fine, but I want to show you just one more thing. What is 10 to the negative first power? It's 1 over 10. Now I have a fraction I can cross multiply. 10 times x equals x plus 3. Whatever technique you want is fine. Change that to a decimal and multiply both sides by x plus 3. Or change it to a fraction and cross multiply instead of equal. Subtract x. Divide. And x is a third. Whew. This is a long video. All right, make this a single logarithm. I hope we're hitting pause in between and not just watching me do all these or frantically trying to keep up. I'm assuming that you're hitting pause. That's the pace I'm going at, that you've already tried these. Okay. Okay, so I made this a single logarithm by combining those two into a single logarithm. Addition is multiplication. Okay, switch forms. I have a log isolated switch forms. 4 raised to the second power. We should be able to do that in our head. X squared minus 9, right? If you don't like that, then just take the time to multiply x plus 3 times x minus 3, and you'll see you get x squared minus 9. Okay. This is 16, so I'm going to subtract 16, and I get x squared minus 25. We should recognize that really quickly as x equals plus or minus 5. I got two answers. I need to go back in and make sure one of them may or may not work. Plugging in the 5, I get a positive number. Plugging in 5, I get a positive number. 5's good. Plugging in negative 5 doesn't work. Final answer, x equals 5. I went fast. Why did it not work? I said x is negative 5, and I just made the statement it doesn't work. How'd I know? You can't take the log of a negative number. 4 raised to some power, right? 4 raised to some power will never be a negative 2. Negative 5 plus 3. Can't happen. You can't take a positive number, raise it to an exponent, and get a negative number. So my only answer is a positive one. All right. Two options. We can switch forms right away, or we can just do the inside part. Since I can see that we can do the inside part, let's. What is the log of 27 base 3? 3 raised to what power is 3? 3. Switch forms. X to the third power has to equal 3. Do I need logarithms now? I have an exponent. Do I need to use a logarithm? No. So what's the difference? Why don't I use a logarithm here, but I did all on that first page? Because the variable's not in the exponent. Here I need to raise both sides to the 1/3 power, or I need to cube root it. Be careful. Just because it has an exponent does not mean I need to use a log. If the variable is in the exponent, then I need to use a log. Okay. Hit pause. Don't forget to hit pause. Switch forms. 4 to the negative first power equals x plus 3. 4 to the negative first power equals x plus 3. This is 1/4, right? We're going to subtract 3, and I get negative 2 3/4, or negative 2.75. Log base 10. Log base 10. The only way that these two can be the same is if this mess here is 7. Subtract 3. divide by 2. Hit pause. Okay, combine, condense. Addition means multiplication. I have a log, I have a log, I have the same base, drop them. Multiply this out, I get x squared. Minus 2x minus 1 more x is a minus 3x. Negative times a negative is a positive 2. Set it equal to 0, so I can either factor it or quadratic formula. I'm going to try factoring for 10 seconds, see if I can get it. Factors of 4 that subtract to give me 3, that's easy. 4 and 1. I want a negative 3. What makes this 0? What makes this 0? Plug the negative 1 back in. Nope. Makes that negative. Plug the 4 back in. That's a positive. That's a positive. X equals 4. Okay. We have 2 logs. I need to make them the same, or a single log. Not the same necessarily, but a single log. They're now a single log, so I drop the logs. Whether it's ln, whether it is log, whether it is some other base, doesn't matter. If this base and this base are the same, I can just drop them. FOIL that, distribute that out. Subtract 10 to make it equal to 0. Use a quadratic formula or factor. I'm going to try to factor real quickly. Factors of 10 that subtract, that one works also. Larger number has to match the sign I want. X equals 2. X equals negative 5. Negative 5 is going to make that negative. It doesn't work. My answer is x equals 2. I'm going to start on the outside one this time. Let's switch forms. 3 base of this power equals that mess. So 3 raised to the second power equals the log base 2 of x. Well, let's do that really quick. 3 squared is 9. Switch forms again. 2 to the 9th power equals x. We're done. Condense my logs. Sorry, I picked the pace up a little bit, haven't I? Hit pause if you need to. Slow down. Slow me down by hitting pause. Condense these logarithms. Switch forms. I have a single logarithm. I'm going to switch forms. 2 to the 4th equals the mess. 5x plus 10 right here. 2 to the 4th. 2, 4, 8, 16. Subtract 10. Divide by 5. It's been almost an hour. All right, I'm gonna hit pause because the bell's about ready to ring. My prep's over, and I'll finish this in a little bit. Okay, switching gears. This is not going to be on the quiz, but it's just good practice. Write the equation of a new function applying the given transformations to that graph or to that equation. So f of x equals left 2 down 5. So there's an x plus 2 up here and down 5. Left 2, down 5. Reflect across the x-axis. So we're going this way. So these need to be negative. And a horizontal shrink. Horizontal shrink. Be careful. Horizontal shrink. That's got to go in the exponent by a factor of 0.5. So I need to have a 2 because it does the opposite. If we're going to shrink it, I actually have to have a 2x. It does the opposite to the x. Vertical stretch by a factor of 5. So that's going to be outside 5 times. Right makes it go x minus, and up makes it a plus. Okay, hopefully that wasn't too bad. All right, this one can be tricky, but it's really easy. We're going to expand. We have a single logarithm, but I have this all up here as, sorry, I'm not sure exactly where it's at, but this is, I had someone come in. So this is just expanding this. These are all written as single logs. This is written as a log of a bunch of things. So I need to know what is the log of A individually in this thing. Well, when I expand that thing, that's just the log of A plus, right, because multiplication, the log of B, plus the log of C. So it's just, there's the log of A, it's 0.6. So it's just 0.6. There's the log of B, which is 0.36. There's the log of C, which is 2.4. And add them all together. And my final answer is 3.36. Do the exact same thing for all of them. Write them as individual logs. Expand it. Hit pause, give them a try. I don't know what A squared is, so I have to get the 2 in front. And now I know what these are. Log of A, 0.6. So 2 times 0.6 is 1.2. Log of B, 0.36. Add them together, and I get 1.56. Repeat, hit pause. Now it's going to be log of A plus the log of C minus the log of B. Grand total, plug in all my stuff. Log of A, 0.6. I don't need to write all that. Final answer, 2.46. No, 2.64. I assume you can plug those in and add and subtract. Okay, hit pause. Expanding, I think we can skip steps now. 2 log A minus 3 log C minus, because it's on the bottom still, 2 log B. Plug in all my information. Plug in 0.6, plug in 2.4. Make sure you're putting it in the right order. And plug in 0.36. Final answer, negative 6.72. Okay, coming to the end. Simply switch forms. That's all you're doing. Rewrite. Guaranteed this is on the test. Just simply rewrite. 3 to the y equals x minus 1. Done. Switch forms. 5 squared equals 25. Go backwards. My opinion, this is the harder of the two. So notice the base of my log is the base of my exponential. So I'm going to write log. The base of my exponential then is now my base of my log. The answer to my log is the exponent. So the answer to my log is x minus 1, the exponent. 9 to the x minus 1 equals y. 9 to the x minus 1 equals y. Okay. The base of my log is the base of my exponential. 11 goes down here. The answer to my log is my exponent, and this is 121. Okay, that got long. Hopefully it helped. Good luck.